Yeah, just in case. Okay, so these are our questions. The first one was 4 times the matrix A, and all you do on that is you just multiply the 4 times each term. So we end up with 4, -4, 0, and -8. That should be pretty much everyone would have gotten that. Adding, the key thing is that they have to be exactly the same size and shape. And so A plus B doesn't work because A is a 2 by 2 and B is a 2 by 3, and so therefore you can't do this. So you can write not possible, or answer doesn't exist, something to let me know you knew that couldn't be done. A plus E, however, can be added because they are the same size and shape, and you just do it term by term. So 1 plus -3 is -2, -1 and 1 is 0, 0 and 2 is 2, -2 and 7 is 5. And if at any point I come up with a number that's wrong using a technique that's right, correct me, because I make terrible arithmetic mistakes. Okay, now then we get to the multiplying ones. Multiplying is where it starts going a little bit more haywire. When you are multiplying, you have to look at the number of rows and columns for each of these. So A is a 2 by 2, and I'm multiplying it times B, which is 2 by 3. And the key thing here is that those two numbers have to match, and then your answer is going to be the outside numbers, 2 by 3. So I'm going to have something that's going to be 2 tall and 3 across. And I do it, and I just, because I need to have some physical activity now and then to help me remember things. My body remembers how to do this, even though I may not have done matrices in years. My body remembers that my left hand always moves across and my right hand always moves up and down. And that's how I remember how to do this. And if you just know that these are the motions of your two hands, then you get it right. Because then you'll be like, oh, wait a minute, this hand ran out of terms. Okay? So, 1 times 2 is 2. 0 times 3 is 0. So this first place here is going to be 2. And for this one, it's in the bottom row, first column. So -1 times 2 is -2. -2 times 3 is -3. And so this position, that is not, it is -6. This is what you guys are supposed to chime in here and say, you can't even do the simple stuff. What's wrong with you? Okay, so -8. You just got to be aggressive about fixing my problems. Okay. 1 times 3, 0 times 1. So 3 plus 0 is 3. Down at the bottom, -3 and -2. -5. Let's see, up here, 1 and 0 is 1. And down here, -1 and -4 is -5. So perhaps that is our answer. On multiplication, I frequently get arithmetic mistakes. This is A times B. Okay? Yeah. So if I switch the order, BA, it is a 2 by 3 times a 2 by 2. And this time, those center numbers do not match, so this one is not possible. Okay. Next, let's look at C times D. Okay, so C is 3 tall by 1 deep. And this one is 3 by 3. Again, those two numbers there do not match, so this one is not possible. But if I switch the order, it's a 3 by 3 times a 3 by 1. Those match. The answer is going to be 3 by 1, the outside numbers. All right, and so when I do that, it's 1 times -1 plus 2 times 2 plus 0 times 2. which is, I think, 3. Then I get 0 times negative 1 plus 1 times 2 plus 2 times 2, which is hopefully 6. Negative 1 times 1 plus 3 times 2 plus 4 times 2 is 15. Okay. And then we have b times c. B times c, b is a 2 by 3. C is a 3 by 1, so my answer will be a 2 by 1. 2 times negative 1 plus 3 times 2 plus 1 times 2 is 6. 3 times negative 1 plus 1 times 2 plus 2 times 2 is 3. Okay? So multiplication is probably where things go wrong. And the key thing is the reason I put this in here as an entire unit by itself is because you got to know what shape the answer is going to be, because you can't even get Excel to do the work for you unless you know what shape the answer is going to be. It will screw things up royally. It'll give you an answer. That's the bad news, is it will give you an answer and it will be garbage. So you've got to know what size the answer is going to be in order to use Excel. The next question was about, are these inverses? And for this, what you need to do is, well, you could calculate an inverse, and if you learned how to do that in another course, great. I didn't ask you to do that. There's all sorts of techniques for doing it. What I just want you to be able to do is test whether things are inverses. And so this was f and g, so I can either look at f times g or g times f. You don't need to do both, one or the other, and the answer should be the identity matrix, which is 1s across the diagonal and 0s everywhere else. And so if I do this, if I multiply these out, if I do the FG order, 7 plus negative 3 plus negative 3 is 1. 7 plus negative 3 plus negative 4 is 0. 7 plus negative 4 plus negative 3 is 0. Up here, I'm going to do negative 3 plus 0 plus 3. Oh, negative 3 plus 0 plus 3. And you keep doing this and you end up with the identity matrix. So the answer is yes. Okay, don't forget to actually answer the question. I will warn you that I usually do something, even if the answer is no, where like the first one is like 1, 0, and then it's like 1, 0, 2 or something, you know, like that, just to make you do more than one term, because that would be too easy, okay? I want you to demonstrate multiplication also. Now on this number 10, it was to find the determinant. There are a lot of ways to find the determinant. The official way is to use minors and cofactors, but I'm never going to ask you to do anything bigger than a 3 by 3 by hand, because those are things that, well, I've used them in some of my other classes, and I just think that of course you know how to do this skill, but also you can test whether or not your program is working on a simple problem, okay, and then run it for something bigger and save yourself a lot of effort. And so I would never test anything bigger than a 3 by 3. And so to do the determinant, not with cofactors, the shortcut method, there are a couple of approaches to the shortcut method, but the one that is generally done is to just recopy the first 2 rows, first 2 columns, I guess, columns, and then go through and multiply your diagonal. So across here, this is 9, that's 12, that's 12. So 9 plus 12 plus 12 is 33. And then come up across this direction, 9, 16, and 9, 34. And so the value is the down direction minus the up direction, which is -1. That's the quickest way to do it. Okay, there are all sorts of other techniques, but that's fast and reliable. I like doing that as long as I promise you I'm not going to ever make you do anything bigger. And then the last thing is about writing equations in matrix form. This is also a key skill for next week's videos, because if you can't do this, there's no point to having learned any of this. Matrix form is going to be AX, not plus B, equals B. Okay, I can make it prettier. Okay, so AX equals B. A is the matrix of coefficients, the numbers in front of the variables. X is the column of variables, and B is like the right-hand sides. And so A is equal to, the X coefficients are 2, 6, and 0. The Y's are 3, 5, and 2. And the Z's are -1, 1, and 3. My coefficient, or my variables rather, are X, Y, and Z. And then the right-hand sides are 11, 12, and 15. And you should be able to go back through and check that if I multiply this times this, I get 2x plus 3y minus z, and that goes in the first position. And the next one is 6x plus 5y plus z. And the last one is 0x plus 2y plus 3z. And that, I'm saying, is equal to 11, 12, and 15, which if I look at each one of these rows, that is indeed one of those equations. Okay? And this is really a very, very critical skill for what we're doing next week. The main thing that people do wrong with this is not paying attention to the order. So the order here, this has to be the X, the Y, and the Z coefficients if the order went in that direction going down. Okay? All right, so